All right, so I think that we can go live here. I have to double check and make sure that one sec. All right, so we should be live presumably everywhere. Yeah, okay, great. We are indeed live everywhere. And the messages look good. I don't know why TikTok's... Let me double check, make sure that TikTok is... I don't understand where the TikTok messages are. Why can't I see them? TikTok messages. Oh, they're there. Okay. They were just in another window. So here's the thinking. Do the TikTok messages actually show up on YouTube? We'll get started in just a minute. I just want to get some tech stuff dealt with. So if you're watching later in the future, just skip forward a minute or two. So TikTok is so YouTube is working, but TikTok is not. It is not grabbing my TikTok chat. There we go. Huh. It's working. Neat. Neat. So if you want to see all the chat, you have to go to the horizontal YouTube. All of the chat will be there. I will not necessarily be answering the questions that show up first on the horizontal YouTube. I'll just answer kind of like as I usually do, kind of going across them. But yeah, can you give us the real facts on 3i Atlas? It's a comet. It's a comet. It's just a comet. I mean, it's a weird comet, but it's a comet. Let me send an announcement on YouTube or on Discord. All right. Why are you in vertical? I'm in vertical and horizontal, and on TikTok. So hopefully everything's working out nicely. So yeah, feel free to go watch whatever you want. Do you believe in abiogenesis? Yeah, it seems plausible, right? I mean, like, look, we know that life is chemistry. Life is just a particular kind of chemistry. And we know that complex chemistry can happen in particularly reasonable environments. Like if your planet is warm and there's a lot of like liquids around and there's lightning and stuff, you could have complex chemistry. I don't see why that doesn't work. Is space pixelated or continuous? We actually don't know. We just don't know. Can you explain what you mean by vertical and horizontal and TikTok? I'm in vertical and horizontal both on YouTube. So you can watch me vertically on YouTube, horizontally on YouTube, or you can watch me on TikTok. That's what I mean. Can you give tips on self-teaching physics? Self-teaching physics is hard. Like, it's just genuinely challenging. So what I would suggest if you want to do it is find a few different resources like Khan Academy, MIT OpenCourseWare, and then like a university textbook, and go through all of them kind of in sync. Pick one that's your primary, and then go through it. And when you get to a part that you don't understand, go find some other sources and learn about that same thing again. That would be my recommendation. Think about this, the universe is expanding, accelerating. What if the universe was rebounding? It could be, but it's accelerating, not just rebounding. Do you think we can upload our consciousness into a robot and it still be us or just a copy? That's not a question for a physicist. How would we determine that space was not pixelated? Well, we could see what's called a dispersion of light. So it could be, if space is pixelated, then we would kind of expect that light would travel at different speeds depending on its frequency ever so slightly. And so that's something that you could in principle measure. Can I make a hydrogen bomb all by myself? No, hydrogen bombs are really tricky to make. Uranium bombs, once you have the uranium, really not hard to make, but hydrogen bombs are tricky to make, yeah. Can you recommend a book or two that talks about the history of people in physics, relativity, and earlier? I don't actually know any. Like, I haven't read a whole lot of history of physics books. How do we prove quantum mechanics is real? Basically by a series of experiments starting in around 1900, extending outwards to like the 1920s. And then by then we had like so much foundational empirical evidence that it was real that, well, that was that. Do you have an informed opinion about the heat death and big rip scenario? So most physicists don't think that the big rip is something that's going to happen. The data that we have just isn't aligned with it. However, we shouldn't like throw it away immediately, right? By the way, for those just joining, whether you're watching on TikTok or on YouTube, if you do have a question and you are dying to get it answered, head on over to YouTube and send a super chat. It'll pop up on my screen and then I can make sure to prioritize that question. Do you think the laws of the universe are non-arbitrary and non-descriptive? Well, I think they are descriptive. Whether they're arbitrary or not, that seems kind of subjective. Is the Earth flat? Is the universe expanding? Is there a chance that the asteroid in 2029 is going to crash into Earth? No, yes, and I haven't looked into it. I think if it's the one I think it is, then I think it has a very, very small chance. Oh. Is the Higgs field a fourth spatial dimension plane, or is it three-dimensional? The Higgs field occupies four-dimensional spacetime. Do you believe that religion and science cannot go hand in hand? No, I think that you can be religious and take science seriously. Why do you believe in the Big Crunch? Well, I don't really believe in it. I think that it's at least a possibility. What's the next most stable metal element and what would its properties be? So we don't know if there are any more stable elements after element 118. I mean, there are no stable elements after element 82, which is lead, if I remember correctly. But at least like uranium-238 lasts for a very, very long time. But as you get to higher and higher element numbers, like uranium is 92, plutonium is 94, and so on. As you get to higher and higher numbers, like 118, you get even less and less stable. Now, it's possible that there's something called an island of stability. The island of stability is this kind of hypothesized region on the periodic table where you have very, very low stability near it, and then at the island of stability, you get extraordinarily high stability. So maybe you even get real stable elements, but more likely it's just that you get something that's more stable than its neighbors. But we don't know. We haven't built those heavy elements yet. We haven't synthesized them yet. What is the name of the survey of scientists that asks about what the Big Bang says about time? Let me pull it up for you. I have it somewhere. So you can find it. Here it is. So you can find it by looking up Copenhagen Survey on Black Holes and Fundamental Physics. I'll paste it in the chat. That's the name of the survey. Why do you love physics so much? Because it's cool. It's just rad. Can we calculate the mass of black hole event horizon? Event horizons don't have mass. Event horizons are kind of invisible boundaries that take up that have volume or have area, but they don't have mass. Isn't the consequence of Hawking's radiation a big rip scenario? What did I misunderstand about the expansion becoming so important that matter turns back into energy? No, so Hawking radiation doesn't imply anything about a big rip. Hawking radiation is just about how black hole event horizon, or how black holes decay. Why are there two YouTube streams? There's one vertical and one horizontal. Some people like watching on vertical, some people like watching on horizontal. Why did quantum mechanics use complex numbers, not just real numbers? So you could use matrices, and then you would only end up with real numbers. But somehow you have to capture the ability for things to overlap in more than two ways, or more than one way. If you just have real numbers, then you can only have cancellations and additions, but you can't have kind of like phases. And you just need that in order to capture all the degrees of freedom. How hard would it be to switch from nuclear fission power to fusion power, and would it be any better? Fusion power would be better, absolutely. It'd be cheaper to run. And the fuel is basically unlimited, and in principle safer because it's never self-sustaining. At least on Earth it would never be self-sustaining. The trick is actually building the reactors. That might take a very, very long time. Any advice for future physicists? Advice for future physicists: go to grad school or go to undergrad, get good grades, go to office hours, go to grad school, Find a professor that you like working with and work with them. By the way, now that there's a few hundred people here, I just want to announce one important fact for those of you who don't know. So I recently launched a new YouTube channel called Dr. Blitz Debunks. This is where you'll be able to find all of the clips of me from debates. All of the debunking videos that I post will be posted there rather than on the main YouTube channel, just because the main YouTube channel will be kept for the live streams and for science content only. So make sure to go subscribe. I can actually just copy and paste the... I'll just pull up I'll paste it into the chat. Both chats, that's the YouTube channel, so go check that out. It's on YouTube. Make sure to subscribe. I want to get it to 1,000 subscribers ASAP so that I can start actually monetizing it because, you know, it would be helpful. Anyway, so go check that out. Let's get back to some questions. What's your take on the implications of Bell's theorem for local realism? Well, it means one of three things. Either locality is not true, either realism is not true, or it means that there's a third thing, or it means that there is a correlation between the experiments that are being run. Those are the kind of like the three assumptions that go in, and so the fact that the inequality is violated means that one of those things is not true. Why does the Earth collapse in on itself like stars do at the end of their lives? Oh, well, so the Earth's gravity just isn't strong enough. And the stuff keeping gravity up, this is the essentially the electromagnetic forces that kind of hold rocks together and prevent rocks from collapsing. They give them structure. Those forces are strong enough to keep the rocks up and hold them up against their own weight. Is wood technically the rarest material in the universe? Probably not. Well, modern theoretical physics research will have major implications for the average person in 100 years. Nobody has any idea. If we could predict that, then we would. What change in research of fine-tuning would convince you of the need for multiverse design? This isn't a physics question, this is a philosophy question. The philosophy question, the fine-tuning argument has a problem because of the so-called electrons in love explanation. I'm gonna shut my door. But yeah, that's a philosophy problem, not really a physics problem. It's not like something that physics research can handle. So from Garba Gaiman with the $2 sending a super chat, thank you. Horizontal streams are superior. Albert Einstein said that. I believe Albert Einstein did indeed say that, actually. Could the laws of nature have been different? Maybe, we don't know. We just don't know. What is black energy made of? Black energy isn't a thing. You're thinking of dark energy. Dark energy is a hypothetical source of energy that we think is that we name whatever is the explanation for the rapid acceleration of our universe, or our universe is currently accelerating. The expansion is currently accelerating. We call whatever is causing that dark energy. How do I understand Maxwell's equations? Well, you should take a second course in electromagnetism. That should probably help. But Maxwell's equations are probably summed up most easily in setting aside the time-dependent pieces, because those pieces matter. That charges produce electric fields pointing outwards. There are no magnetic charges. Electric fields don't circulate, magnetic fields do circulate. Magnetic fields circulate around currents. That's the way to think about Maxwell's equations. And then there's, of course, the time-dependent electric fields cause magnetic fields, and time-dependent magnetic fields cause electric fields. But that's a little bit more of a complicated piece. When people say Einstein's theories on gravity fails in fully explaining quantum physics, does that only apply when things are smaller than the Planck scale? No, it applies roughly at the Planck scale. That's roughly where things start to break down. When will we be able to replicate atoms? I don't know what you mean by replicate, but like we can make new atoms out of old ones. How does a star burn through its last fuel so fast that it would cause a supernova? So the point is that during the end of a massive star's life, the pressure and density, so normally stars are burning hydrogen, and burning hydrogen is very, very efficient. So basically it's able to the heat it's able to produce given the pressure. So there's gravity pulling it in, which produces pressure. That produces fusion in the core, which produces a lot of heat. And so the pressure is big enough, the heat that's produced is big enough given the pressure that it keeps the star fairly big. But when it runs out of hydrogen, immediately that pressure goes away, and so it collapses a bit. and then the pressure increases, and so it starts fusing helium, and then it starts fusing into carbon and oxygen and so on. So essentially what happens is up until the very, very end, when it starts fusing iron, every time it runs out of the fuel, it collapses a little bit more to increase the pressure, because the next fuel source is always less efficient. And then it gets to iron, and it collapses, and it can't fuse iron into heavier elements to generate energy. Fusing iron takes energy. So it just keeps collapsing until it basically bounces off a hard neutron core, and that's what the supernova is. Advice for nuclear engineering students? I've never been a nuclear engineering student. I don't know what good advice is. If you could infinitely condense water with infinite pressure, would it form a black hole, and how? Yeah, I suppose. You wouldn't need to do it infinitely, though. What do you think about the potential black hole stars that were discovered by JWST? I haven't actually looked into it yet, but it's on my to-do list. But if true, that's groundbreaking. Bob Lazar is a hack. Stop the stupidity. Thank you for joining. Thank you for becoming a member. Does the magnetic property of iron relate to the zero nuclear potential? No. It's just the case that light things fuse into heavier things and produce energy, and you can also split things to produce energy. And so there must be some place where you can't split them or fuse them to produce energy. And from Fear's interaction with the $5, thank you so much for the $5 super chat, by the way. What's the greatest challenge of a creator god would need to address to make a 6,000-year-old universe appear billions of years old? Well, look, I mean, they could just do it, right? They could just make it appear 6,000 years old, but then it just seems like that they're deceiving us because they're leaving behind a whole lot of evidence. That's the issue, right? They're leaving behind a whole lot of evidence that the universe is actually 14 billion years old, even if it's not. So, like, it just seems like a deception, like a grand deception, if you will. How are grapes so round? Well, they're not. They're like ovally. Can you explain phase space and degrees of freedom? Yeah, so phase space is essentially the ways that a system can be configured. So it's both the positions and the momentums that a system can be configured. Now, if it's one particle, then phase space would be 6-dimensional because there's 3 different dimensions of position, and there's 3 different dimensions of velocity or momentum. And so you get a 6-dimensional phase space. Now, a degree of freedom it's a little bit vague, but the way of thinking about this is if you write down the total energy of your system, the degrees of freedom are the number of degrees of freedom of your system are the number of independent things that are squared in your energy formula. So if you look at the formula for kinetic energy, it's 1/2 times the velocity squared, but the velocity squared is 1/2 times the velocity in the x direction squared, plus 1/2 times the velocity in the y direction squared, plus 1/2 times the velocity in the z direction squared, and then multiply all of that by the mass. So you have 3 degrees of freedom just from the kinetic energy. And then you can also have vibrational stuff. You can have all sorts of other degrees of freedom. From eFont with the $2, how do you drink your coffee? I drink it black with with some sugar. It's fairly boring. So from Tim for Pele with the $5, are most physicists okay with QFT plus GR as an EFT and don't really care about behavior at the Planck length, or is quantum gravity interest pretty common? Well, it's common in my circles because those are the circles I run in. But generally, I think most people just don't care. Most physicists do quantum stuff. They do condensed matter, or they do particle physics, or something like that. So that's most physicists. Or they do like complexity stuff, which is there's also a lot of quantum there. Most physicists just don't even worry about gravity at all, because there's a lot of stuff to be learned about microscopic stuff still. But of those who do, I'd say a reasonable chunk actually care about quantum gravity. Are you a better physicist than Newton? I suspect not. Does information have mass? Depends. Generally, no. Depends on what you mean. What everyday tech other than GPS destroys flat Earth beliefs? Gyroscopes. Gyroscopes on planes. If black holes can store information holographically, how exactly is it encoded on the horizon? We don't know how it's encoded. We just think that it is. Do you think that debating flat earthers lends their belief equal validity in comparison to the globe? I know it generates revenue, but overall it might not be ideal to... No. I'm not of the opinion that we should... look, I think 20 years ago, it was probably correct to just ignore people who have these ideas, because they don't really have a way to spread their ideas. However, with the democratization of streaming platforms, short form content, YouTube, etc., with the democratization of all of those things will spread on their own. And we tried this. We tried ignoring it, and it didn't really work because now, like, flat Earth is very broadly, like it's accepted by a lot more people than you would think. And so, like, it's like 10% of the United States are flat earthers. So I think that the mistake that we made was ignoring them, and I think that showing a large audience that they're stupid, I think that that's a better idea, or that they're misguided rather. I think that maybe that'll work better, because what we've been doing, ignoring them, not working. Do you think the way physics is taught to the average person is more helpful or misleading? I don't think it's misleading. I just don't think it's great. Do you think basic logic should be required to be taught in schools, and why isn't it already? There's kind of an intent to do that. It's just not done well. By the way, if you're spamming, please stop it. Otherwise, I will mute you. Larry Beck, thank you for the $5 super chat. I appreciate you. What is Newton's left-hand rule? There isn't one. At least not that I'm familiar with. Okay, so that's spam. You get a mute for 5 minutes. Please don't spam. How fast? No. Why are there exactly 3 generations of particles? Coincidence or deeper symmetry? We don't know. This is another, we actually don't know. There might be a 4th, right? But yeah, we really don't know. Does quantum immortality have any scientific basis, or is it purely philosophical speculative? It's purely philosophical. There's not really a scientific basis for it. And in fact, even the philosophical basis is very, very weak. Do you know anything about the Boogosphere? Just that it was probably fake. Like, I actually did some digging into to see if like anything that was being claimed about it was actually true. And there was like one guy who like looked at it, and everything else was sensationalized about it. Are you doing debates today? Nope, not on Tuesdays or on Wednesdays. Why do you choose physics as a subject? Because black holes are cool. I mean, look at that thing. It's so cool. How do you read papers without getting overwhelmed? Well, often I do get overwhelmed, but I usually just skim them. Like, I'm at the point in my career, I probably should be reading more, but I'm at the point in my career where I don't need to read papers in their entirety. I'm often just looking for a particular result. Is it true what Michio Kaku said? Can an atom or electron be in 2 places at once? Yeah, it's called quantum superposition. And yeah, it's definitely a real thing. By the way, well, never mind. Can you explain your work shown in your profile picture? It's hard for me to even remember what it was, because, so that was like 3 years ago, by the way, like 3.5 years ago. And it was just scratch work. It was just scratch work that I was doing with my PhD supervisor. And I just thought it was like a good background. So it was just scratch work. Are white holes real or hypothetical? They are not. They're almost certainly not real, right? So there's kind of 2 issues. One, we have like theoretical models that explain how black holes form. We have no theoretical models that explain how white holes form. So we don't have a reason to think that they can form in our universe. Setting that aside, if white holes did exist, we would expect that they'd be very, very bright. Like how black holes are black, they don't let anything in. White holes just shove stuff out all the time. And so one would expect then that we would be able to see them. They'd be very bright, but we can't. We haven't found any. Do you think dark matter exists? Yeah, I think so. What was the most challenging part of your PhD candidacy? So a lot of my PhD work involved basically like a really huge calculation. We're talking like if it was done by hand, it would have been like hundreds or thousands of pages of calculation. We're talking like hundreds of thousands of terms each line. So maybe not hundreds of thousands, maybe tens of thousands of terms each line. So this was an enormous calculation. And so what I ended up doing is I ended up basically using a computer to do the calculation, which it was able to do. The thing is in order to make it publishable, I had to go through with my PhD supervisor, because his name would be on the paper too. We had to go through line by line and check every single line of the calculation on the computer. And that took a very long time, and it was horribly boring. So that was probably the worst part. Does dark matter is much heavier than gravity? Gravity doesn't weigh anything. Well, it kind of does, but that's setting aside. Dark matter is just like regular matter, but it doesn't interact with light, and so we can't see it, but it still has mass, so it still has gravity. Why do you lean toward infinite universe over finite with current thermodynamics understanding? So an infinite universe is what's implied via general relativity, right? If the universe is spatially flat, three-dimensionally spatially flat, but spatially flat nonetheless, meaning that our spatial slices have no curvature, then there are basically two options, or roughly two options. There's the option where it's like you go in one side and come out the other side. And then there's the option where it's just infinite in all directions. And the infinite in all directions kind of has fewer assumptions. So I'm going to go with that one because that one basically wins by Occam's razor. As a secondary school student, what do you recommend to help me become an astrophysicist? I read a lot of in-depth astronomy stuff and already look at uni stuff for fun. Just keep doing what you're doing. Make sure you get good grades so you can get into a good uni. And then when you get into uni, make sure that you go to office hours, you get good grades, you do research if you can. It's just be a good student. That's what you need in order to get. Once you get into grad school, then there's a whole bunch of extra questions. Gravity is a theory and has always been a theory? Well, yeah, it's a theory being an explanation. It's also a phenomenon. It's like an observed empirical factual phenomenon, you know, right? And then it's also a law. There's the universal law of gravitation. Jacko, I don't review theories, and also please don't spam. So spamming gets you a mute for 5 minutes. Keep that in mind, mods. Has quantum gravity been figured out yet? No, it hasn't. What's your advice for people learning physics? Pick up a book. There's a really good book that I read when I was a youth. This book, A Brief History of Time by Stephen Hawking. It's a bit outdated now because it was written, I think, in the 80s, and I think it was revised in the 90s. But it's super, super good. So I would recommend it. In a post-CCC JWST world, combined with how little we know, I missed that question. How confident in the Big Bang are we? Still very confident that JWST hasn't influenced our confidence in the Big Bang at all. Sorry, I missed what you said to the mods. So this is for TikTok mods. Spamming, whether on TikTok or on YouTube, if you're spamming, you get a mute. That's just what happens, okay? So no spamming. No spammerino in the chatterino, okay? What's the great attractor? So the great attractor is almost certainly just a whole bunch of more galaxies that are on the other side of the galaxy, or that are on the other side of our galaxy. So essentially think of it this way. Our galaxy is like a big pancake. So you can look up out of the pancake, you can look down out of the pancake, but if you try to look through the pancake's in the way. And so the great attractor is in the direction of through the pancake. So likely there's just a whole bunch of galaxies that we just can't see because the pancake's in the way, but the gravity is still affecting our galaxy. Do you believe in energy with zero radiation? I don't know what you mean by that. How can energy increase as big crunch occurs? Well, look, I mean, it depends on the model. I've constructed a model where the entropy actually decreases as the big crunch occurs. But there are other models where the crunch is, I mean, like generally entropy increases when, say, a star collapses, when a star forms, the entropy increases. So like, it's at least plausible that that could happen. It just depends on the dynamics. Love your shorts. They touch on things that other pop science channels don't touch on. Are these topics that interest you? Yeah. So like I have really broad interest as far as physics is concerned, as long as it's not condensed matter. I just don't really care for condensed matter physics. But aside from that, I have really broad interest as far as physics is concerned. Now my specialty is in like relativity. And so I focus on that a lot. Relativity, gravity, differential geometry, but like cosmology, black holes, that kind of thing. But I have generally really broad interests. And so I end up teaching myself about those things so that I can make content for you guys. Yeah, condensed matter, algebraic QFT, yeah, both of those are bad. Do you subscribe to the idea of the heat death of the universe? I don't, at least I'm not like certain of it. If you had asked me, 2.5 years ago, I would have said, yeah, definitely, that's what's definitely gonna happen. However, we've had data that's come out since, and we're just not as sure anymore. What's wrong with condensed matter? I just find it so boring. Now, I'm sure it's interesting to other people. I just find condensed matter, it feels like engineering and chemistry to me. It just doesn't feel like physics. And I get that it is physics. It just doesn't feel like it's me. So I just find it really boring. What does the universe look like at the speed of light? Well, you can't go the speed of light. There is no frame of reference that is at the speed of light in which I can answer that question. In terms of particle physics, specifically fusion tech, do you think replicator tech is possible? It's like replicator tech is like in principle possible, but like not for like 100 years. Like at least 100 years, right? Is there any model of the death of the universe that you lean more towards? No, at this point I'm pretty agnostic. How did Stephen Hawking write several books when all he could do was blink an eye? How did he ever finish a chapter? I don't know. I don't know the details of the way that he communicated. All I know is that it's very impressive. So what's the most likely situation of our universe in the coming trillions of years? We don't know. We just don't know at this point. Can you give some references you like that support your belief in dark matter and dark energy? So look, so dark matter and dark energy are very different things. The references are going to be very, very different. However, the evidence for dark matter comes in basically, I want to say like three ways. So first, there's the rotation curves of galaxies. Rotation curves of galaxies are faster than what we expect they should be based off of the speed or based off of the observed mass. So for those who don't know, stars orbit the centers of their galaxies. The more mass that's in the galaxy, the faster the outside stars orbit. And we see stars orbiting faster than they should be given the amount of stars that we can see. So it seems like there's more mass in the galaxies than there should be, than what we can see. So that's one piece of evidence for dark matter, but it's not the only piece. Then there's also gravitational lensing data. So if you look at galaxy clusters, these are enormous clusters of hundreds or tens to hundreds of thousands of galaxies. They bend light. And the amount that they bend light depends on how much mass there is. And it turns out that you can kind of map where the mass is depending on how the light is being bent. The light from behind it is being bent. And what you find is that it's being bent in places where we don't see that much matter. So there must be some kind of matter that is producing that gravitation that we can't see, dark matter. And then third, there's a final piece of data from the cosmological data, namely that if we look at the cosmic microwave background radiation, it has certain features that would only make sense if the universe has a certain amount of mass. And so we take that mass to be dark matter. And it exactly agrees with the dark matter that we see in the other two cases. Now, as far as dark energy goes, it's not that we really have evidence for dark energy, like some direct evidence like we do for dark matter, or indirect evidence. It's rather that dark energy is just whatever is the explanation for the observed accelerated expansion of the universe. That's it. And we see that the universe's acceleration or expansion is accelerating. So there must be some explanation. Where are all the super chats? Nobody's sending them, which is fine. People don't have to. It just, it just gets your question answered more quickly. Why is there a thought? It's not. Do you agree with Hawking saying that before the Big Bang makes no sense, or do you agree more with Sean Carroll's model or something else entirely? I'm pretty agnostic on the issue. At this point, I'm pretty agnostic. We just don't have enough data. Do you think we've been visited by anything from another galaxy or planet? I do not. I think it's just too far. Does decreasing entropy always entail a reversed arrow of time? It depends on how you understand the arrow of time. Most physicists understand the arrow of time to be just the direction of entropy increase, in which case, yeah, that would be entailed. But that's not necessarily true. Like, we could just be wrong about that. I still haven't figured out how we're seeing into the past when we look at different planets. So look, the point is that light takes time to get to us from wherever it started from. So if something is 100 light years away, then that means that that light started out, if it gets to us today, it left 100 years ago. And so if we're looking at, say, let's say that we're looking at a planet with life on it, and let's say we see that they're let's say that the light that's getting to us is the light that was emitted when they were driving their trains or whatever, right? They were like steam engines. So that light has taken that. So it was 100 years since their steam engines were around and emitted that light to get to us. So it's been 100 years since then. So they probably have more advanced tech now because it's been 100 years. From Jeffrey Wayne Boyce and from None of, thank you guys both for the $1. I appreciate that. Why is it that nothing can travel faster than the speed of light? Why is that the limit? Look, so this is the answer I usually give. Essentially, there are two options. Either a universe could have an upper limit for the speed, or it could not. Our universe happens to have an upper limit for the speed. We don't know why. It just happens to be that way. And things without mass are going to travel at the fastest way they possibly can. Light doesn't have mass, so it travels at the maximum upper limit speed. From Baltachi with the $10, if the cosmic microwave background is uniform across the sky, how do we know it's really the afterglow of the Big Bang and not just combined redshift light of countless stars and galaxies? Well, so first of all, we need to account, I guess that there's a few different ways that we can think about this. So the first thing is that we can see the galaxies, right? The light that we can see is galaxies. Now, if you're saying, oh, well, this is redshifted so far that we can, that it just kind of blends together because there's so many of them, well, maybe. But we would need to explain A, why it's redshifted, and B, why it's so uniform. Those are the two things to explain from the CMB, right? So the redshift can be explained by motion away from us, and expansion explains motion away from us, right? And expansion also explains uniformity. However, if it's just a bunch of galaxies, why would they be redshift? Why would they all be uniformly redshifted away from us? Yeah, so I guess that's the second point. It's also the case that the spectrum just doesn't match. The spectrum is a thermal spectrum, whereas the spectrum from galaxies are generally not thermal, right? Also, I guess that there's a whole bunch of so there's a whole bunch of spectroscopy stuff too, but graviton, that's a good point. Could nuclear transmutation present a sort of alchemy in the future, or is the energy too big of an ask? The energy is too big of an ask. That's what it boils down to. Is there a good analogy for superposition? You don't even need an analogy. You can just think about it exactly. Whenever you hear a guitar play a chord, you're hearing superposition. You're hearing multiple waves overlapping each other. That's all superposition is. How would a muon be created at almost the speed of light? Well, anytime that you have a nuclear reaction, muons can be created. Well, not anytime, but there are lots of different ways that you can produce a nuclear reaction. And if that nuclear reaction happens at a high enough energy level, like the two things crash into each other at a sufficiently high energy, then one of the outcomes can be a muon that's shot out near the speed of light. Any thoughts on the multiverse, many worlds concept? So these are kind of, I think of them as two separate things. So there's the multiverse, the cosmological multiverse, which is just that like our universe is one but a pocket of many universes that are separated spatially. They're very, very far away from each other so far that they can never interact. The second thing, the many worlds, is a quantum thing. And that's about how our world, our universe, perhaps all of physical reality, is in a superposition of many different states, and all of those realities are equally real. So I think that the many worlds interpretation is probably correct. I'm not sure about the cosmological multiverse view. How come light behaves both like a particle and also like a wave? Which is it really? Light is a wave. Sometimes that wave can take on particle-like properties, but it's always a wave. Hey Blitz, I want your thoughts on the moon. Do you think it's weird? No, I don't think it's weird. It's the moon. It's the most normal thing. Blitz, is the second a duration that is universal, or could other sieves have totally different working units? Yeah, of course they could. Yeah. I mean, the second is, it's just a choice that we made. It's a certain number of, cesium-133 vibrations. They could have chosen some other different thing. Why do physicists study pseudo-Riemannian manifolds, or am I wrong about that? So relativists, people who study relativity, do because our universe is well modeled by a pseudo-Riemannian manifold, right? So like, our universe has 3 dimensions of space, 1 dimension of time, which is, if you view that as a manifold, then it would be a pseudo-Riemannian manifold, in particular a Lorentzian manifold. Your thoughts on entropy? I actually have a video planned that I'm going to release probably tomorrow or maybe the next day about entropy, explaining what it is. But entropy you can think of as kind of like the amount of information that you've left on the table when you make measurements, right? The amount of information, so there's an amount of information that's macroscopically available, and the entropy measures how much information how much microscopic information you're not capturing from the macroscopic information. From Stop This Stupidity with the $2, you rock, Dr. Blitz. Thank you so much. That's so sweet, so kind of you. How much wood could a woodchuck chuck if a woodchuck could chuck wood? 42, just 42. Dr. Blitz, how do I become a billionaire? You don't. How do we know the Big Bang is valid? Well, there's just a lot of evidence for it, right? So there's the cosmic microwave background radiation, which is kind of like the original evidence. It's in some sense kind of the afterglow. It's uniformly, it's light that we can observe in all directions. It has the same temperature, it has the same wavelength and all of these things. And so in some sense, this is kind of like just the universe being slightly warm. And so if the universe was smaller in the past, then it would have been hotter, and that's kind of what we would expect from the Big Bang. There's also evidence in the form of the expansion of our universe. Everything in our universe seems to be moving away from us. That's well explained by the universe expanding. And then finally, there's more evidence on top of this, but there's also evidence from something called baryon acoustic oscillations. These are basically sound waves that would have occurred in the early universe. We can basically track them as overdensities and underdensities in the distribution of galaxies. But yeah, so it's basically that. Are you familiar with the Reissner-Nordstrom metric? I am. I don't usually study Reissner-Nordstrom because charge stuff is weird and annoying, but I do like to look at Kerr black holes, and I am like at least, you know, familiar enough, like I could probably derive the Reissner-Nordstrom metric. Can quantum mechanics explain subjective experience, or is it classical neuroscience sufficient? I suspect the latter. I suspect classical neuroscience is sufficient, but we don't know. What profound previous scientific belief of yours has changed with time? I used to think that the universe would certainly end in a heat death. I no longer think that. Was there a period in a younger universe where stars lived and died much faster to account for the generations of stars that led to our heavier elements? Yes, basically. These are called population 3 stars. They have very, very short lives. They live on the order of 10 million years, whereas our star will live for about 10 billion years. Do you play Elite Dangerous? I haven't played it in a while, but I spent a very long time on Elite Dangerous, and I probably have a few thousand hours on it. Do you play disc golf? I do not. What's the quantum field? So there's a lot of quantum fields, but a quantum field, well, first I should explain what a field is. So a field is merely an assignment of a number or some quantity, maybe a vector, whatever it might be, to every point in spacetime. So you just, if you feed me a position and a time, I can spit out a number. So it's a function. It assigns a number or a quantity to every point in spacetime. A quantum field is just what happens when you take that function, that rule for assigning a number to every point in spacetime, and then you quantize it. And what that means is fairly complicated, but you basically allow it to behave not as numbers, but as operations on states. From Veronica Cromit with the $10, thoughts on Juan Maldacena and anti-de Sitter space? Someone who worked with him sent me an article about it. Thought it was interesting, learned later from a friend this is controversial. No, so Juan Maldacena is one of the great physicists of our time. Brilliant, super, super brilliant. And what you're referring to is the ADS CFT correspondence. So this is anti-de Sitter, the anti-de Sitter space corresponding to the conformal field theory. And it's actually really not controversial. This idea is really highly regarded by a lot of theoretical physicists. People who think it's controversial are definitely in the minority here. From Tim for Pele with the $5, can you give some details on the differences between principal and tangent bundles? So principal bundles are bundles that, I can go into the details here, but principal bundles are bundles that are related, that have a different symmetry group necessarily than the symmetry group of the underlying manifold, right? Or different symmetry group than a principal bundle can be, I should define what a bundle is. You have a manifold, you attach stuff to the manifold. So you can kind of move vertically along the vertically away from the manifold, and you can move horizontally along the manifold. So the tangent bundle is a type of bundle, but a principal bundle is just a more general thing. So a tangent bundle is a particular, well, it's not necessarily a principal bundle, but it's a particular kind of bundle. A principal bundle is a bundle that behaves in a certain way under the transformations of certain groups. I can go into the actual technical details, and maybe I'll make a video about it at some point. But actually explaining what the details are without going into a whole bunch of definitions is probably too much for the live stream. And of course, the tangent bundle is locally Euclidean, right? It's just a whole bunch of RNs glued to the manifold. Caleb Brow with the $5. Thank you for the $5 super chat. No message, just a thank you. Is it possible to shrink to the size of an atom and live? Do you think there will ever be? I don't know what that question means. How much longer until we find alien life around our technological level or higher? We may never. Is he reading comments from TikTok or YouTube? I'm reading comments from all of them. What are your thoughts of Jacobo Grinberg? I've never heard of him. Can you explain the Penrose process? Yeah, so the Penrose process is a process for generating energy around a black hole. And essentially what it does is it robs a black hole of its rotation. So imagine that you have a I don't know, a box that can split into 2 pieces, or a particle that can split into 2, that can decay into 2 pieces, whatever it might be. If you send that particle into the ergosphere of a rotating black hole, when it decays, if it decays or if it splits in just the right way, so that one part goes closer, that part will basically get negative energy, and it will kick the other one out with more energy than it came in with. And so you can essentially extract energy from the black hole that way. I made a video on this a while ago, and there's some nice diagrams for it. But essentially, it's a way of extracting energy from the rotation of the black hole by sending stuff in and having half of the stuff fall in and half of the stuff leave. What is the Hamiltonian used for in quantum mechanics? The Hamiltonian is what defines the operator whose eigenvalues are the energy. So it's basically what okay, there's two pieces. It defines the operator whose eigenvalues are your energy, and it also governs time evolution. And this is very closely related to the Noether's theorem, namely the statement that energy conservation is what happens when you have time translation invariance. So that's what the Hamiltonian does. It generates time translation. It's the operator that generates time translation, and it returns your energy values. From Seth Wilburn with the $5, thank you so much for the super chat. Hey, Dr. Blitz, love the content as always. Question, how viable is the hypothesis of proton decay? Do we have any experimental evidence for it? The hypothesis was viable perhaps 30 years ago, and it was like a good hypothesis, like the math was sound. However, we've just been looking for like 30, 40 years at this point. We just haven't found it. And so either proton decay is very, very slow, or it just doesn't happen. And then from the guy who does with the $5, thank you for the super chat. Thank you so much. Maxwell's equations or Michelson-Morley experiment led to the idea that the speed of light is measured the same in all reference frames. So the Michelson-Morley experiment led to that idea, and then you can kind of read that back into Maxwell's equations. Sorry, my nose hurts. Weird. Now, originally Maxwell's equations were understood to be that there was like an ether that these waves were traveling through. And that just wasn't present in the equation. But then from the Michelson-Morley equation, they observed that actually there is no ether. And so it must just be something more fundamental. How many black holes have been tested, and if so, what was used to test them? Well, we've observed them. So we can't make them in a laboratory, so we can't really like fiddle with them experimentally, but we can observe them. We can look at them and look at a lot of their properties. And it's got to be on the order of thousands or millions or tens of thousands at this point. Caleb Brow with the $2. How do we know that uranium-lead dating is accurate? Well, we know the rate at which uranium decays. This is pretty easy to measure. You just get a Geiger counter, you stick it up next to some uranium, you weigh the uranium, and then you can use the rate of decay and the mass of the uranium to establish how long it would take for half of it to decay away. That gets you the half-life. And that's a consistent thing, so we know that the half-life doesn't change with time. That's just a fact of quantum mechanics. And then it's just a matter of finding some sort of system in nature where the uranium is trapped in and there's no lead present. And zircon crystals do that very, very effectively. Zircon crystals trap uranium and they don't let any lead in at the moment of crystallization. And so if you go find lead inside the zircon crystals and you find some uranium, well, then you think that, well, the lead must have come from uranium decaying. And so, of course, you can use the half-life the half-life that we know that we've established to figure out how long ago that zircon crystal formed. From Jay with the $2, JJ with the $2, thoughts on order from chaos emerging naturally? I think it's totally plausible. In fact, we kind of see that happening all the time, right? I mean, just think about star formation, for example. You initially have just like a giant cloud of gas, and then like a supernova happens nearby, disturbs it a little bit, causes a slight overdensity, gravity causes it to collapse, and then you end up with planets orbiting a star. Could we use a small probe and send it near the speed of light and use it to get data? Yeah, absolutely. There was this idea called Project Starshot, which has been essentially canceled now thanks to our unfortunate administration. Thoughts on 3i Atlas, the interstellar object, alien probe? No, probably just a comet, an interstellar comet. How do you define Einstein-Rosen bridge? It's not really a well-defined notion. It's essentially just like what happens if you go to negative radius in a Schwarzschild black hole. How influential do you think Run 4 at the LHC will be within physics? I suspect that they're not going to find anything new, but rather that they will just get more accurate data on stuff that we already knew existed. How long did it take to get your PhD? It's a good question. So I went from undergrad straight to PhD. This is a fairly common thing in the US, at least for STEM fields. And so for the first 2 years, you're basically taking classes and you're earning a master's. And then after that, you get admitted to PhD candidacy, at which point then you're kind of working on your PhD. So I spent 2 years on the master's part and then another 5 years on the PhD part, which is a little on the slow end. My first advisor and I didn't work out well. So I spent 9 months with my first advisor and we didn't accomplish anything. So essentially she dropped me, which was unfortunate, but probably for the better. And then I found the person I ended up graduating with, so that delayed me a bit. But, you know, other than that, anywhere between 5 and 7 years is pretty normal. How's my day going? It's going pretty well. Will AI disrupt society drastically? It kind of already has, hasn't it? Are you a determinist? In some sense, I'm a quantum determinist, if you will. Thoughts on Norton's dome? Norton's dome is a mathematical pathology. I don't think it has anything to do with classical physics, though. I don't think that it means anything about as far as classical physics is concerned. It's confusing the map with the territory. Do you have a day job? Sort of. I mean, in some sense, science communication is my day job. So like that's, well, I make enough money from science communication that I can spend a few hours every day on it, including this and making informative videos. Spend a few hours every day on that, and then I can spend the rest of my day doing scientific research, which is how most of my days go. I usually start my scientific research by around noon, and then I work till 5 or 6. What'd you do your PhD in? I did it in, specifically it was in conformal geometry with applications to the ADS-CFT correspondence, but the kind of general view was, it was differential geometry and relativity kind of stuff. Thoughts on Berkeley's physics program? It's excellent. World's highest IQ holder claims Jesus is God. Thoughts? IQ does not correlate with ability to know the supernatural. I don't know what to tell you. If time is a dimension in space-time, does that make determinism inevitable? What's the best argument against determinism? The best argument against determinism is quantum indeterminacy. That's basically it. Is Jupiter a failed star? No, not, I mean, it's sort of a failed star in that it's heavy and that it's gas, but it would need to be like 13 times bigger to be a genuine star, right? So it's not close. Have you brought any other PhD guests on to debate? Maybe. If so, they haven't announced themselves. How does entropy work inside a home? Can that help dry homes to reduce mold? Entropy? No. No, entropy is not like a substance. What's the most expensive piece of scientific equipment that I've used? Most expensive piece of equipment that I've used that I knew how much it cost was probably just a pretty new lathe. I used to work in my, well, not work, sort of work. I used to make stuff in the machine shop when I was an undergraduate. And I was trained on the lathe, and I was trained on their mill and a few other things, and I would use the lathe pretty frequently. With €6, thank you so much, Yoshkin. With €6, could civilization that lives near black hole colonize galaxies at sublight speeds, since from their perspective time is slow and they have lots of it? So from the perspective of the planet near the black hole, the things very, very far away will move very quickly, yeah. Their clocks will move much more quickly. But that doesn't mean that the colonists would feel it move more quickly. They would feel it move at the normal time. So, I mean, but like we could colonize the galaxy at sublight speeds. It would just take 2 million years, right? Have you met Michio Kaku? No, and I probably won't. What parts of math are most important for theoretical physics? I'm horrible at statistics. It just depends on what physics you're doing. If you're doing quantum field theory, then algebra is probably the most important, maybe with some differential geometry. If you're doing relativity, differential geometry is the most important. If you're doing experiments, then statistics are the most important. It just depends on the physics that you're doing, right? Oh yeah, so there's another, I should mention this again, there's another YouTube channel now. It's a second YouTube channel where I'm going to be posting debunking videos, so the stuff that I often post on TikTok will go on that YouTube channel rather than the main channel, and I'll also be posting clips from the debates, you know, like individual clips so that you can see the individual debates rather than having to watch the whole thing to see the good bits. So these are going to be individual debates that are going to be posted on this extra YouTube channel. The YouTube channel is currently posted in the chats on YouTube. Can I post it in the chat on? And And if you want to see it on TikTok, go to the link tree. You go to the link tree in my bio, and the link to that YouTube channel is there. So please make sure to subscribe, by the way, to that channel. I want to get it to 1,000 subscribers ASAP so that I can monetize and it can actually, you know, help me produce a sustainable environment so I can focus more on my research. Based on what you have observed of dark matter, do you think it would move faster or slower than light? If it's matter, it moves slower than light. That's just what matter does. You're not a physicist. My PhD in physics and my publications in physics journals begs to differ. Is it hard to find a job in your country as a physicist? Yeah, generally. I mean, look, the job market for physicists is always, for academic physicists at universities is always hard, just because there's more people who graduate than there are jobs. However, generally, so it's something like 10% of people who finish with their, I think it's 10% of people who finish with their PhD end up in academia. Make of that what you will. Why is winter so cold even if the Earth is closest to the sun during that season? Right, so winter is only closest to the sun during the northern hemisphere's winter, and the reason why it's cold is because the actual distance to the sun is very, very insignificant. Like it's a very small amount, it's like a few percent. But the point is that the Earth is tilted away from the sun. The northern hemisphere is tilted away from the sun at that point. So the sun comes in at a lower angle, and so that sunlight is spread out over a larger area. That coupled with the fact that the nights are longer and the days are shorter just means that there's less energy getting to the northern hemisphere during that time. Spin and solar mass equivalent seem understandable enough, but is there a useful analog for a black hole's charge? Is this an electromagnetic force measurement? Oh, no. When a black hole is charged, it's literally the total electromagnetic charge it has. It's literally that. Yeah, it's literally the electromagnetic charge, or the electric charge, rather. You should read about the University of Cape Town black hole singularity theory. The universities don't usually have theories. Professors usually do. Most of the sun's energy that reaches Earth is in light, not heat. Yeah, that's true. And? Is sunlight more energetic than normal photons? I don't know what you mean by normal photons. Photons can take any part of the electromagnetic spectrum. Sunlight is mostly visible light with a bit of UV and a bit of infrared. So you can have more energetic photons than that. You can have gamma ray photons, which are more energetic than infrared or UV or visible. You can have less energetic photons, like radio waves. What new data has made the heat death of the universe less likely than before? Well, so the heat death of the universe was kind of predicated on the universe on dark energy being governed by a cosmological constant, or being described by a cosmological constant. However, there's data from an observation, or like I should call it an experiment, but it's not an experiment. There's data from the DESI collaboration, which suggests, it's not definitive yet, but it suggests that the amount of dark energy, that the kind of pushing force of dark energy is not constant. And so that kind of, if that's the case, then the whole heat death, then the idea of the heat death kind of goes out of the water, right? What's my favorite color? I like green. Thoughts on Interstellar and the Tesseract Other Dimensions? Interstellar was a good movie. The last 15 minutes, though, were not very scientific, and the Tesseract stuff is not real. What causes tides? Just the moon or something else too? So the moon is responsible for about 2/3 of our tides, and the sun is responsible for the remaining 1/3. Have you seen the conceptual idea of how to make a black hole bomb? I have, yeah. And it's actually on my to-do list of things to make videos about, because it's an interesting idea. What do you regard as the most promising theory of everything? Nothing that's out right now, I think, is the most promising. Are particles just waves interacting with fields? Particles are waves, and they're waves whether they're interacting or not. Does heat death just not just refer to complete spreading of all energy? Yeah, but if we don't know that the universe will continue to expand forever, then it's not clear that the energy can spread out infinitely or can spread out forever. What's your take on Hossenfelder and Weinstein? Sorry, not Weinstein. Sorry, the hiccups. What's your take on Hossenfelder and Weinstein saying little has come out of quantum mechanics in 30 years? I would say that they haven't read a lot of quantum mechanics. There's been a lot. Now, maybe not foundational stuff, but that's because foundational stuff is really hard. How do the photons that mediate the charge escape black hole if it's charged? Photons don't mediate charge. Photons don't even mediate fields. Fields mediate fields. And the question of how the electric field gets out from a charged black hole is the same as the question of how the gravitational field gets out from a black hole. Namely, fields are continuous. Fields are, in particular, magnetic fields are space-like. So they can just pass through the event horizon, no issue. They can leave the event horizon. But yeah, I mean, like, you have charge. You have charge in the interior, so you have an electric field. The electric field is in turn going to have, it will occupy space, and it has to fill all of space. And so you can't have a discontinuity. So there's just going to be a smooth normal Coulomb field, at least in the low gravity regime. Do photons ever lose all the energy they start with? If they are absorbed, then yeah, that energy's gone. Do you allow for boxes for more complex questions? No, I generally don't do that anymore. I don't know what 20 DKK is, but oh, that's 20 Danish kroner, which is about $3 US dollars. Thank you, Sheep, for the 20 Danish kroner. What's the most concise evidence of a globe? Concise? Sunsets. The sun goes down, it doesn't go away. Do you think a cyclic universe is more likely than heat death? At this point, I don't know. At this point, I'm pretty agnostic. Do physics have any explanation for information? I don't know what you mean by explanation for information. I don't know what explanation information needs. Information is just a way of quantifying, like, the uncertainty of something, basically. How do you include the kinetic energy of a photon for its energy? In some sense, all of its energy is its kinetic energy. It doesn't have any mass energy. Is my nose okay? What's wrong with my nose? Oh, I think I might have a pimple inside my nose growing, which always hurts, and I think that's what's happening. From Stop the Stupidity with the $2, how can Wolf-Rayet stars exist? I don't know. I haven't actually read it, but Wolf-Rayet stars are on my to-do list of things to read about. I don't know a lot about them, so I just can't answer it. Sorry. But actually, you know what? I'll make sure to move it up to the top of my list to make a video about, just because, you know, you sent $2. I at least I owe you an explanation of some kind. Wolf-Rayet stars. I think it's pronounced Rayet. From Steen Cassier with the €5. What's your understanding of the view of, if the sun would disappear, we would only know 8 minutes of gravity instantly? Thank you, I don't quite see. So look, gravitational influence propagates at the speed of light, just like how light does. So if the sun disappeared, its gravitational influence would stick around for another 8 minutes. It would spread out from the center to get to us, and it takes light 8 minutes to get to us, 8.5 minutes or so. It takes light about 8.5 minutes to get to us from the sun, so it would take the sun's gravitational influence about 8.5 minutes to get to us as well. If the universe is expanding, but space itself is what's expanding, what exactly is it expanding in? It's not expanding in something. You just have to think of the way that we measure distances as changing. Although, actually, there's another video I'm going to make at some point in the near future. It's also on my to-do list, which is about how you can actually view the universe as not, you can actually view space as not expanding, and there merely being an all-pervasive field that just forces galaxies apart, and the space itself is static. You can actually do that. Like, it's entirely consistent with our observations. It's just kind of a Newtonian way of viewing it. Could a telescope with a sufficient diameter allow us to watch the Big Bang? No, because telescopes view in optical, they view in electromagnetic waves, and unfortunately, the universe was opaque to electromagnetic waves starting about 380,000 or up until 380,000 years after the Big Bang. And so up until that time, the universe was just completely opaque. So we would never be able to see it regardless of how big our telescope is. We can only see back until 380,000 years after the Big Bang. Could black holes just be stars with gravity so immense that the escape velocity of it surpasses the speed of light and thus it cannot leave the surface, and since no light approaches us it appears dark? That's what's called a that was what's called a dark star. This was first proposed by, oh, who was it? It was some British guy in like the 1700s actually. And essentially that's what a black hole is. The thing is we just don't know what's going on in the inside. It could be that there's just some more dense form of matter there that we can't see. It's certainly not a star, because stars require nuclear matter, and nuclear matter can't survive at that density. But we don't know what it is. What's your IQ? I have no idea. If the universe is infinite, could infinite energy be possible? Yeah, sure. Just not in one particular place, just spread out, yeah. Double slit experiment, eyes, photons interact with electrons. That's why electrons act the way they act. What do you think? So the eyes don't release photons. The point is that if you were to do this with, if you were to, this is a thought experiment, by the way, like this is not a thing that's typically done. But if you were to do an experiment where you have electrons interact with photons that determine which slit it goes through, then yeah, those photons will affect the electrons because they're interacting with them. Are we actually running out of helium? If I remember correctly, yeah. But I don't know. I haven't checked. It's just what I've heard. Is it possible our universe is one giant black hole? I actually think it's not possible, given, so if you assume general relativity is true, I think that you can actually prove that it's not possible. This is a project that's on my, this is a project that's kind of on the back burner. It's like a solo project I'm going to work on at some point. I just haven't gotten around to, working on it yet. But I think that you can actually prove that if general relativity is true, then our universe cannot be in a black hole. You don't know your IQ, you don't want a racist, misogynistic exam score. Well, so I think at some point in the past when I was a kid, I think my mom had me tested because I was put into some sort of program, like some gifted program or whatever as a kid. But my mom rightfully, totally reasonably, never actually told me the number. Because if the number was, whatever the number was, it was apparently high enough to get into a gifted program, right? And that would be so bad for my ego. It would be so bad. And it's because it's not like it's actually meaningful, right? Like it doesn't really mean much. Anyway. What is the color code for a 3200 ohm resistor? I actually used to be able to read resistor bands, but it's been like 10 years since I've had to do that. Does entanglement move from photon to photon through absorption to new emission? Entanglement move from photon to photon? Entanglement move. Entanglement doesn't move between photons. I think that you're a bit confused about that. Photons, or entanglement is a thing that can exist between photons. But it's not a thing that moves, right? From Conspiracy Music Studios with €5. Thank you so much. No question, but a comment. Thanks for doing these live splits. Always brilliant. And the irony of someone repeating proof gravity in the chat. Yeah, we always get some of those, right? We as humans keep wanting to know what something is made up of. When will this stop? Well, until we find either the bottom or we find that there is no bottom. Thoughts on the Kalam cosmological argument? I think it fails in both premises, actually. Or at least I think that neither of the first two premises are justified. Do you have any publications, any published papers? Yeah, I have over a dozen. But no, I tend not to share them just because I try to keep my academic work separate from my science communication work. That said, if you really, really, really want to know what I'm researching and you want to contribute to my research and you want to get personal acknowledgments in my research articles, then there's a really, really obscenely expensive way that you can do that on Patreon. You can basically be like a medieval patron. It's like obscenely expensive, so only do it if you have like FU amounts of expendable income. But yeah, if you want to support me, and you want to know about what research I'm doing, and you want to get your name acknowledged in the future publications, that's what you should do. Blitz PhD, what do you think of doing asteroid capture and mining at Lagrange points? It seems like maybe it's useful, but it seems super expensive right now. Oh, by the way, I should mention, you should join the Discord server. If you haven't already joined, join the Discord server if you're 18 plus. It's a good way to ask me questions, talk with like-minded people. Obviously, it's free and all of this. There's a link in the description of the YouTube video if you're watching on YouTube. There's also a link in my link tree in my bio. When satellites use gravity assists around the moon or planet like Voyager, the energy they gain must come from somewhere, and so does that mean the planet slows down its orbit? Yes, but planets are much, much heavier than orbiting satellites, and so the actual speed that they change by is negligible. But yeah, they are stealing that energy from the orbiting planets, absolutely. Are physicists cooked with emergence of the AI? No. At least not yet, because I use AI a bit in some of my work as to find me references and stuff. But whenever I ask it to actually do anything challenging, it fails. It fails it fails so spectacularly. Can tachyons ever be proven to exist, or are they simply only a theoretical particle? They're not even theoretical, they're hypothetical. We don't have any model that makes sense of tachyons right now. Why is gauge symmetry so fundamental in modern physics? It's a good question. In some sense, gauge symmetry is fundamental because it's a type of symmetry, and symmetries gives rise to conservation laws, conserved quantities. So in some sense, we kind of expect any kind of symmetry to do that. But gauge symmetry is a little bit more special because it's kind of the promotion of like a redundancy to a genuine symmetry. And I don't know if there's actually like a good explanation for why gauge symmetries, why it's gauge symmetries in particular. I guess what gauge symmetries do is they allow you to describe things simply mathematically. And then the price you pay for them being simple is that you have redundancies, and those redundancies are the things that would, if you got rid of them, would make it more complex and give rise to the forces. But we don't want to do that, so instead we write them in terms of gauge symmetries. What do you think 3i Atlas is? It's a comet. It's a comet. Like, it's just a weird comet. What is your favorite experiment that you have performed? So I did the photoelectric effect when I was an undergrad as part of my advanced lab course, and I thought that was really cool. What are the fundamental differences between the lighthouse effect and the projection effect in astrophysical observations? I'm not familiar with either of those. I'm not an astrophysicist, right? I'm just a regular old physicist, right? I'm not familiar with those. And I could Google them and maybe answer your question, but it's probably not worth doing. I'm a mechanical engineer thinking about going back for a bachelor's in applied physics for funsies. Do it. Could you be wrong about 3i Atlas? Yeah, I could be wrong about the sun rising tomorrow too. Does the time dilation at the event horizon of a black hole prevent anything from crossing it? From an outside observer's perspective, yeah, but from the thing falling in, they cross it in finite time. Idea for a 5th grade science fair experiment. Oh, no, I have no ideas. How much are pop science clickbait headlines making your job more difficult? Oh, so much. Oh, they make it so difficult. It's such a pain. It's awful. What do you think about that black chemist? Well, I don't think about him much, but he steals a lot of my content. Or by steals, I mean like he uses my content without like linking me. And then he's like trying to clout chase, which is kind of cringe. Like he's made like 4 or 5 videos about me at this point, which again, cringe. In like the last 2 weeks, right? If the space-time is expanding and not the universe, then what is the universe expanding in if the medium in which the space-time expands? So look, so space is what's expanding, not the space-time. And space is the universe in some sense. And so it's not like space expanding rather than the universe. So space is expanding and it's carrying everything in the universe with it. But it's not expanding in something, at least in the standard understanding of physics, standard understanding of cosmology. Space, there's nothing outside of. It's not like emptiness outside of physics. It's just it doesn't even make sense to ask what's outside of space. Space is everything. When do you all use differential geometry the most? Well, I use it in my everyday life or in my everyday work because I'm in some sense a differential geometer who pretends to be a physicist and vice versa, right? Like half my publications are in differential geometry journals and the other half are in physics journals. So like I use it all the time because I kind of wear 2 hats, right? Hey, I'm a human physician. How can I loop myself back into physics, not pop sci? So look, the thing is pop sci isn't necessarily a bad thing. You just have to find good sources. So for example, PBS Spacetime YouTube channel, a few million subscribers. They're like the gold standard for science communication in my view. I think that they are probably the best large physics YouTube content creator. And in my view, generally, your best science communicators, or the people who are going to most accurately represent the physics, are going to be the people who work in the field. Not just people who worked in the field 20 or 30 years ago, although they can still be quite good, but people who work in the field. It's called PBS Spacetime, like PBS, the public broadcasting station. It's called PBS Spacetime on YouTube. And the guy who runs it, Matt O'Dowd, he is a working physicist. He works at CUNY in New York, right? Like he's a working physicist. So he represents the science really well. He does a really good job explaining without oversimplifying. If I could make content as well as he did, I would be happy. So yeah, you just have to find good sources. And then pop science is fine. From Stop the Stupidity with the $2, how much do you know about Ton 618? I know that it's in a very, very large black hole. Other than that, it's not that special. What about someone like Veritasium? Heard conflicting opinions. Veritasium's, I haven't watched Veritasium in a while. And the reason is because it seems like the quality has changed. I don't know why, but it seems like the quality has changed. Is there evidence of more dimensions? There is not. We have evidence of 4 dimensions of spacetime. That's it. I have not heard of Epic Spaceman, no. Who is stealing Dr. Blitz's content? It's a guy named That Black Chemist on TikTok. Well, PBS Spacetime isn't the largest science communication platform. I think that Veritasium's bigger. I think that Kyrgyzstats might be bigger. PBS Spacetime is one of the biggest. And he deserves it. In my view, it's the best. It's the best large science communication content on the internet, at least as far as physics is concerned. I suspect that there are probably some very, very talented science communicators who just don't have an audience. And so I just haven't seen them. Is the shadow of a four-dimensional object three-dimensional? In principle, yeah. What college did you go to? I'm not going to tell you that. How can we know the mass of the universe if we don't even know what we're looking at is still there? So we're looking at the mass of the universe as it falls on our past light cone. But generally, the mass doesn't disappear, right? It's not going anywhere. So we just look, like, we can assume that the mass that we can see is the mass that's still there. And we can just measure. We can just like basically count how many stars are there, how much gas is there, that kind of thing. We can measure the strength of gravity, etc. What does it mean that space is expanding but space-time isn't? So space is expanding in time. So at a later moment in time, space will be bigger than at an earlier moment of time. That's all. What's your side and argument about gravitons? Gravitons, I suspect gravitons exist. I don't really have an argument for it. It just seems like, it seems super plausible. What is the credibility of Navier-Stokes equation that even though used in many fields, but could it be wrong? And if we understand it, could we tell the behavior of fluids with 100% surety? The Navier-Stokes equation is correct. It's not wrong. You can derive it from microscopic stuff. In fact, there was actually like a huge breakthrough paper like 6 months ago or something where they actually did that. They derived the macroscopic behavior from Navier-Stokes from microscopic stuff. It is correct. It's just we don't know how to solve it generally. Does time exist in all places of the universe? Yeah. Yeah. Why does the universe exist at all instead of nothing? It seems like nothing can't exist. That seems like a contradiction in terms. He's on TikTok and YouTube, so lots of comments. Yeah, so if you want to see all of the comments that are coming in, you can go to the horizontal YouTube stream, which is on the main channel. Both YouTube streams are on the main channel, but go to the horizontal stream on the main channel, and you'll see all of the comments from both YouTube streams and from TikTok. We don't know how to solve what. So the Navier-Stokes equation. The Navier-Stokes equation is an equation that governs fluid dynamics. It describes fluid dynamics, I'm sorry. It governs fluid dynamics, and so the trouble is we don't know how to show that every set of initial conditions has a unique solution for all future times. Like, we just don't know how to do that. What does it mean that the Higgs boson, the Higgs field, gives particle mass? So what it means, so particles are fields, right? Particles are excitations in fields. And those fields interact with each other. And one of the interactions that the other particle fields have with the Higgs field is that it just gives you, a term in its equations of motion that looks identical to mass. It's kind of a technical way of phrasing it. The analogy that's often given is that the Higgs field, you can think of it as like space-time molasses, and the particles are traveling through the space-time molasses being slowed down, and that makes them behave as if they have mass because they're moving slower than the speed of light. But that's just an analogy. If space-time is expanding and not the universe, then what is the universe expanding in? It is the medium in which the space-time so space-time is not expanding. Oh, I already answered that. I'm sorry. What caused the Big Bang, or did time itself begin there? We don't know. We don't have the information on that. Can logic itself be a perception like a self-referential trap? That seems like a question for a philosopher. Is water level at rest? It depends on what you mean by level. I mean, like, in some sense, yeah. So water conforms to the forces that are acting on it. That's what it means to be a liquid. Now, on the surface of the Earth, there's one dominant force, so that's the gravitational force. And at least as a good approximation, that gravitational force points in a constant direction. It always points this way. Now, as you move further and further, it changes direction as it goes around the Earth, right? But at least as a first approximation, it just points in a constant direction down. And so in that sense, yeah, if that's the only force acting on the water, then it will be perpendicular to that force. However, if you had a large body of water that was stationary, right, then that was stationary enough, then it would not be flat, it would not be level, because it would conform to the curving gravitational field. I missed a question that I wanted to answer. Does light lose energy as it travels through space? We don't have any evidence of this. Oh, okay, let me rephrase. We don't have any evidence that it happens for any reason except the expansion of space-time, or the expansion of space. As light travels through space, space expands, and so it stretches the wavelengths, which causes it to lose energy, yeah. CS2 or Valorant, I don't really play either. Have you heard of Dr. Sam Rajanson's research on distinguishing? No, I have never heard of him. If time equals count of collapse events in proper time, would two identical decoherence clocks at different gravitational potentials accumulate different tick counts of the same? So we don't know how to square simultaneous collapse with relativity. So we have no way of answering that question, if collapse even happens. Any thoughts on the book Road to Reality by Roger Penrose? It's on my to-read list. I just haven't read it yet. I really should, though, because, you know, it's Roger Penrose, right? What's the least amount of gravity that exists? Quantum gravity. Well, the weakest gravity you'll find between galaxy clusters. Can you explain how neutrino CP violation led to matter-antimatter asymmetry? Never quite understood this. We don't think that neutrino CP violation led to matter-antimatter asymmetry. We actually don't have an explanation for matter-antimatter asymmetry yet, because all of the CP violation that you'd like, all the CP violation that we've observed, is not enough to account for this asymmetry that we see in the universe. So it's just not clear. Now, it is true that CP violation can give rise to matter-antimatter asymmetry, just only a little bit. What's your take on virtual particles? I keep hearing conflicting accounts from reputable physicists on whether it's an actual physical phenomenon versus just a calculational technique. It's just a calculational technique. Anyone who says otherwise is trapped by the math. They're stuck. What's the most mathematically elegant structure you know that still has no physical interpretation? Four-dimensional Poincare-Einstein spaces. How about that? I mean, in some sense, they have a physical interpretation. It just doesn't apply to our universe, right? Could the Michelson-Morley experiment have detected gravity waves if our motion was measured under more precise instruments? In some sense, that's what LIGO does, yeah. Sorry, I thought this was therapist. Oh, we probably have a new crowd here, so I'm going to spam it again. So I have a new YouTube channel that I'm trying to get to 1,000 subscribers. There's like 500 of you guys watching right now, so make sure to go subscribe to this. New YouTube channel where I'm going to be posting clips from debates. I'm going to be posting debunking content there. I'm going to keep my main channel just for science content and for live stream. So make sure to go subscribe to the new YouTube channel. If you're on, I posted it in the live chat on YouTube. If you're on TikTok and you want to go subscribe, which you should, make sure to go to the link tree in my bio. It's somewhere up this way or something like this. There's the YouTube channel is called Dr. Blitz Debunks. So go subscribe to that, please. I want to monetize it ASAP so that I can, so that I can start having a sustainable source of revenue in case TikTok goes away, right? The YouTube channel is called Dr. Blitz Debunks. And I have 2 videos posted there, so you should go watch them. They're both quite funny. Is FTL travel possible or anything that moves faster than light? We don't have any, there's not really a good reason to think that it is possible now. I mean, like, at least in our universe. There are ways that we can, like, talk about it hypothetically or theoretically, like via warp drives, essentially, but those seem to require matter that we know can't exist, or that we don't have reason to think that they exist. What do you think about Sabina Hosenfelder? I think that she's been audience captured. I think that she's too cynical. Is mathematics discovered or invented? I think that mathematics is invented. Sorry, I just want to make sure that I'm not missing anything. Not missing any cash apps or anything, because I will answer questions from cash apps as well. Is there any true way to get perpetual motion? No, not if the laws of physics are true, which, they probably are. TikTok isn't going anywhere with Dr. Orange Idiot Power. Look, so the issue with TikTok is that it's being bought by American companies, and I suspect that the monetization schemes will change. Currently, my monetization is I monetize quite well, but who knows how that'll change, and I'd really like to not have like a huge change in my income all of a sudden just because of politics. So that's why I kind of want a, you know, something more stable like YouTube, if you will. Can you mass debate on live? I don't know what you mean by mass debate. I mean, I guess so. I used to go into flat earther lives and then like 8v1, but that's kind of boring. Bet you $5 that matter is converted into space-time at the core of a black hole. Okay. All right, so we went from 144 to 182 subscribers. That's great, but we're still like 800 shy. So, you know, keep working on it, right? Bro, science can be disproved. Physics can also be disproved, so perpetual motion can be achievable. This argument is science can be wrong, so perpetual motion is possible. Like, perpetual motion is logically possible, but given the current laws of physics, it's not. Without throwing too much shade, is there a science communicator that you really don't like, and if yes, for personal and professional? Oh, no, I'm fine throwing shade. Ashley on TikTok. I don't know if she has a YouTube channel. Her account name on TikTok is Modern Day Aristosthenes, which is like wildly egotistical or narcissistic. And also, she just like is wrong about a lot of things. She just gets stuff wrong like a lot, and she oversimplifies things to the point of spreading misinformation. And she has an enormous audience because she's excited and she talks really excited. Like, I just think she does a bad job. There are so many better women science communicators than her. I don't know why she's one of the big ones. Like, I just don't understand it. Anyway, sorry. I just think that she does a disservice to physics, physics and mathematics, because that's what she ends up doing most. Anyway, sorry for the rant. Oh, I missed. Yeah. How does gravity generate energy? I know its potential energy translates into kinetic. Yeah, that's it. That's the whole thing. Do you think parallel universes or dimensions can explain paranormal activity? No, I don't think so. Who are you talking about? Don't worry about it. If you really want to know, go rewatch the, go scroll back into the YouTube stream. Chicken Chaser with the 5 Australian bucks. Can you explain why time passes differently for someone on Earth versus someone traveling at a much faster speed? It's hard to wrap my head around. So, look, this is a fundamental feature of our universe. The reason why it happens is a bit complicated, but if you accept one postulate that everything with mass travels through space travels through space-time at the same rate, which is the speed of light, then it becomes significantly more understandable. So if everything travels through space-time at the same rate, if you travel through space more quickly, then you must travel through time less quickly. And that's it. And no, I wasn't referring to Astro Alexandra. Astro Alexandra is wonderful. She does a great job. I'm actually super jealous that Astro Alexandra does as well as she does. But she's like, Astro Alexandra's excellent, great content creator, does a really good job of getting people excited without like making stuff up or getting things wrong. Absolutely love her content. Definitely jealous of her ability to get engagement, her ability to drive views. She's really good. Are there physicists working on time travel, or is it accepted that it's not possible? I don't know of any experimentalists that are working on time travel, but there are definitely theorists who are like thinking about ideas that involve time travel. Definitely. Have you ever thought about collaboration with other pseudoscience debunkers or participating in debates or on debate-focused channels like Modern Day Debates? I've been on Modern Day Debates, I think twice actually, or maybe it was only just once. But I've been on Modern Day Debates. I've done collaborative debates with people. Generally, the thing is I just don't reach out. If people ever reach out to me about being interested in doing that, then often I'll just say yes. Like if people ever reach out for me to be on their podcast, assuming that it's not like some random podcast that nobody listens to, like I generally just say yes to all of these kinds of opportunities. If you could solve one unsolved problem in physics tomorrow, which would you pick and why? I would want to know how quantum gravity works. That's it. Yeah, I wasn't on with MC Toon. I think I was supposed to be on with MC Toon. Who was I on with? I think I was on with Peter. Peter Merkley. Could you explain quantum gravity? No. Oh, well, I can explain the idea. So the idea behind quantum gravity is that just like how we have classical electromagnetism and then we have a quantum theory of electromagnetism, we have classical gravity, which is like general relativity, but we don't have a quantum version of it, and we need one. Yeah, Angela Collier is also really good on YouTube, but I think that she's better for like the podcast listener rather than like conveying lots of information in like a compact way, in a like compact, efficient, and accurate way. I think Angela Collier is a different kind of science communicator. She's excellent, and I've been in contact with her. I've asked her for some advice before. She's really devoted, but I think that she just makes a different kind of content than PBS Spacetime. By the way, we got 11 TRY, which I don't know what that is. It's equal to about a quarter, but thank you, Zajux, for the 11 TRY. How did I meet Ian? That's a good question. We just ran in the same circles in the debate streams. I think I actually met Ian through Parker, if I remember correctly. Hi, Dr. Blitz. I've just finished my first term of studying EEE. Any advice to get me through college? Not for EEE. I've never taken EEE, but go to office hours if you're struggling. It'll make it so much easier. Your professors want to help you if they're good. Can a physicist be both theoretical and experimental? I guess, yeah, but it's just both of them take up so much time. It's just not really feasible anymore. And I don't know of any that are both. Can a person of normal intelligence earn a physics degree? Yeah. If consciousness is a quantum phenomenon, then the theory that your consciousness will always be alive, given that it would pick the universe where one doesn't die, this is if we know many worlds interpretation is true. Yeah, so the point is you shouldn't live your life that way, because A, not all events that occur are splitting events, right? Only events that are governed by quantum mechanical processes are splitting events. So most ways that you die will be classical. Second, as an entity, you should care about all of your future branches, not just the one that lives. And if most of them die, then you should be worried about that. Collier is pretty serious and academic with her content. She absolutely is. She's a little bit more meandery, more conversational, which I think is like, and this is not to say that she's like not serious and not academic, she's not rigorous. It's just the way that she presents herself. Like I've talked to her, she doesn't script her content. Whereas I imagine PBS Spacetime does. PBS Spacetime kind of scripts their content in advance, and then they convey exactly the information that they want to convey and nothing else. Whereas Angela Collier, she doesn't. She just kind of talks about the thing that she wants to talk about with all of the knowledge that she has. So absolutely, just a different style of thing. Hi, Dr. Blitz. I'm a third-year biophysics PhD student. Do you have any advice on quals? Oh, so my first time, are you talking about the written exam or the oral exam? Because I can never remember which one's which. So there's the prelim exam, which is written from, at least at my university, the prelim was written and the quals were like an oral exam after 2 years or after whenever. So I actually didn't pass my quals the first time around. I mean, I passed with adjustments, so I had to go and write up a thing afterwards. All I can say, like, the thing is that as well, if you're a third year, you probably know what your research is on. When I was doing my quals, I didn't really have a good grasp of what my research was. I was still really new to it, so I just didn't give as good a presentation as I could have. Yeah, I wish I had good advice. I've just never been on a qual committee. What do you think is the biggest hurdle to overcome to get a physics degree? Mathematical fluency. Like, seriously, the hardest thing about a physics degree, and this is just from being an undergraduate, the students, when I was an undergraduate, the students who struggle the most are the students who were not mathematically fluent. Like, think of mathematics as a language. Your professors are speaking in mathematics for the entire lectures of your physics degrees, at least once you get past your first year of physics courses. And so if you're not fluent, you're going to be struggling to understand them. After that, I think that if you're motivated, if you like physics, then you will not have a hard time. But mathematical fluency is hard to get to, right? Like that's not something that everybody had the privilege to be given as a young person. I think mathematical fluency, like language fluency, is best learned at a young age, and it can be very, very hard. I mean, like, it's not impossible, but it can just be very, very hard to get to that level if you didn't have that exposure as a young person, which is unfortunate. And I wish that we did a better job teaching young people. Do Gödel's incompleteness theorems indicate that we are in fact a goldfish in a tank? No, not necessarily. What exactly is the fourth dimension in physics? So there are 4 space-time dimensions. There's 3 dimensions of space, 1 dimension of time. That's it. Then they're not ordered in any particular way. What's a question in physics that seems simple but actually has no clear answer yet? That's a tough one. Well, basically a lot of why questions. Why are things the way they are? Why are there three families of quarks and 3 families of leptons? Why is why are there 4 dimensions of spacetime? Like these kinds of these are easy to state, but they're not necessarily like obvious. They don't seem obvious. What are the odds statistically of becoming mathematically fluent when you are not at all? Oh, I don't know what the odds are. And that very much depends person to person, right? Black holes can be managed and destroys in matter. I don't know what that means. Maybe start a... how is Neil deGrasse Tyson viewed by the physics community? I think he's not... I don't think he's looked down on, but he's not taken too seriously. Most people in the physics community don't really engage with pop science. I think I'm actually, at least from the people I've spoken with, I think I'm actually in the minority here that I actually engage with pop science stuff, and I do science communication, and I read like a lot of the pop science stuff just because it's interesting to me. That's what got me into physics in the first place, and I like keeping up to date with it. So like, I think that most physicists just don't really have a strong opinion. I think that they're like, oh yeah, he does a good job like exciting the youth, but you know, they don't like. He's not viewed as like a paragon amongst physicists, right? He's just like a guy who's doing a good job exciting the youth, kind of like Bill Nye. Becoming mathematically competent is a lot like an athlete. It's genetics to an extent. I actually don't know how true that is. I don't know if there's any evidence to support that mathematical competency is genetic. But it is like being an athlete in that it requires a lot of exercise. It requires a lot of training, like a lot of practice, right? Astrophysics doesn't use the scientific method? Sure it does. That's a weird statement to make. Could physics reveal truths that math can't express? Possibly. The algebra of Lie? Is that a question? Where should you start with below high school level understanding of mathematics? You should start with pick up a high school level math textbook, and then the first thing that you encounter that you don't understand, just backtrack until you do understand. What would a bounded universe look like? Yeah, this is a great question. So a bounded universe would look a lot like the surface of the Earth, right? The surface of the Earth is a bounded two-dimensional manifold, right? So it has finite surface area. However, it doesn't have an end, right? There's no end to the surface of the Earth, but even though it's finite. So our universe could look a lot like that, but just 3-dimensional. You will not be able to visualize it, but that's how it could look. Question, theory or derivation of equations, what is more important for a higher understanding of physics? Those two things are the same thing. The theory is how you do the derivation of equations. How good are you at statistics? I'm very not good. I mean, I'm probably better than your average person, but like I have like probably an undergraduate understanding of statistics because I don't need it for my research. Do you like math as much as you like physics? I like certain kinds of math as much as I like physics. Differential geometry, great. Algebraic topology, not great. Give us an example of when astrophysics used the scientific method. So you make an observation. You see something that you don't understand. So you go and you form a hypothesis to try to explain that. And then you go and you look for... then you go and you look out in space and you see if you can confirm your hypothesis by other observations. And then you can analyze your data. And then you can, come to some conclusion. That is the scientific method, right? That's like the whole business of astrophysics. Also, there is computational astrophysics, which uses simulations to do your experiments. And that you can absolutely do as well. Question, what does it mean for the universe to be infinite if we can't interact with most of it? Oh, well, look, I mean, like, things can be infinite without us being able to touch them, right? Like, for example, you could have things with mass that you can't see, but that doesn't mean that they don't exist. It would just be the way that the universe is. How long does it take to get a PhD? After you have a master's degree, usually it takes between 3 and 5 years. That's pretty normal. What created the energy that created the Big Bang? The energy didn't create the Big Bang. It's a common misunderstanding of what energy is. Energy is a property of systems. That said, we don't know what caused the Big Bang. How do you integrate relativity and quantum physics into one general theory? Nobody knows. If I knew, I would be winning my Nobel Prize. No, where's the dependent and independent variable? So it depends on what kind of thing you're doing. If you're doing computational astrophysics, then you can have tons of independent and tons of dependent variables where you just tweak parameters and then you see what happens in your simulations, right? Is it true that scientists claim they can see the beginning of the universe? Sort of. We can see kind of the afterglow of the Big Bang. This is the cosmic microwave background radiation, and we do this all the time. Like this is studied. This is very, very well studied. Michio Kaku has a great book, The Science of the Impossible. Everyone here should be reading it. I disagree. I think that if you're going to read anything by Michio Kaku, it shouldn't be from after 2008. Why is the Fibonacci sequence important? It's not really. As a physicist, do you believe in a creator? No, I don't. But you can. Nobody's stopping you from doing so. How could the scientific method test simulation hypothesis, which might be unprovable? Well, so if you're talking about it like a scientific theory, then it can be tested. You just have to figure out what predictions it makes. If you're talking about the philosophical thing, then that's philosophy, not science. Why after 2008? He kind of went down the rabbit hole in like a bad way, starting like the late 2000s, even starting in the early 2000s, but some of his books from the early 2000s are still quite good. Do you believe we will ever be able to travel faster than the speed of light? I suspect not. Such is the nature of things, but I could be wrong. What's the significance of an electron being able to diffract and interfere around the nucleus? Oh, well, I mean, it depends on what you mean by significance. Like the fact that this happens shows that these things are waves, right? Which is a big deal. It's like it has big philosophical implications. But I guess it depends on what you count as significant, right? Can you explain how the Higgs field gives particles mass, or is there no good simple explanation? The standard pop science explanation, which is decent, is that you can think of the Higgs field as being like molasses, like a field of molasses, that particles that interact with it have to slow down as they travel through. And by slowing down, that means that they must effectively have mass because they're not traveling at the speed of light anymore. Stop the Stupidity just sent 5 gift memberships. Thank you so much, Stop the Stupidity. I appreciate that. That means a whole lot. That's so generous of you. Thoughts on tachyons? They probably don't exist. Do you think the universe is infinite? I lean that way, yeah. Of course, I don't know that for certain, but I think that that's probably the simplest explanation for the data we have. What's stopping us from quantum gravity? Explain in detail. It seems as though it should be pretty easy. No. What is the point where one realizes, oh, fuck, this is hard? Yeah, okay, so I will answer that question in a minute. Just have to address the super chat. From Last Johnny with the 5 New Zealand dollars. Thank you. What distance change? Why does distance change at light speed? Well, distance doesn't change at light speed. Distances change near light speed. You can't go light speed, so I can't address that. But near light speed, distances change essentially because of the geometry of space-time. It's a fact about the geometry of space-time itself. The details are kind of complicated, but if you look up the Einstein train length contraction thought experiment, you'll come up with a fairly intuitive explanation. Now, to answer the question about quantum gravity, why it's hard. So there's a way that we come up with quantum theories given a classical theory. So if you take classical electromagnetism, there's basically an algorithm or like a set of rules that you can use to kind of turn that into a quantum theory. Now, the trouble is if you take those rules and you try to do them to gravity, you can prove that it doesn't work. And the reason why you can prove that it doesn't work is because the amount of steps in the algorithm that you have to run is infinite for gravity. And you can prove that it has to be infinite for gravity, but it's finite for any other classical theory, like classical Yang-Mills or classical electromagnetism, whatever it is. Those are finite, and so you can do this in a finite number of steps, and you can actually achieve this process with a finite number of measurements. The issue is that every extra term you have to add, these include the infinite number of terms for gravity. Every extra term you have to add, you have to run an experiment to basically determine what that term should be like. And so you have to do an infinite number of experiments in order to make a quantum theory of gravity. This is what's known as the non-renormalizability of quantum gravity, or of general relativity rather. Now, there are other more conceptual issues, namely, the way that we typically talk about quantum field theory is that quantum field theory takes place on a space-time. We don't know what it would mean for the space-time itself, which is how we describe gravity. We don't even know, like, conceptually what it would mean for the space-time itself to be the thing in superposition, for example. That's really, really hard to think about, because the way that we talk about how space-times change is how quantum fields change is the way they change through time. But if time is part of the quantum field, now it becomes very, very complicated and very, very confusing to even make sense of this question. Anyway, good question. How do we get energy from the movement of protons in our mitochondria? Doesn't this mean that, oh, I don't know, that's a biology question. I'm not a biologist. What fact pattern about the pattern of stellar evolution could we discover that would have the most practical benefit? I'm a theorist. I don't know stuff about practical benefit. Sorry. Do you think that quantum physics is completely discovered? I want a future in research. Oh, I mean, there's still tons of work being done in, like, the foundations of quantum physics. And there's a ton of stuff about applications to quantum physics. Like, all of condensed matter physics is just quantum physics of matter, and that's the most active field of physics that exists right now. If you said scientists can see the beginning of the universe, how can it also be infinite? We can see the afterglow of the Big Bang, and that is sort of the boundary of the observable universe. It doesn't seem like that those two things are the same. Infinite in size doesn't mean it's unrelated to whether or not the universe had a beginning. What is on the frontier of physics research? Oh, like everything. Like a lot of things. Do you understand how magnets work on the deepest level? Yeah, I made a video about it a while ago. It's a good video in my opinion. Essentially, the reason why permanent magnets work is because you have electrons around the atoms that make up the magnet, or electrons in the atoms that make up the magnet, and these electrons have spin. And those spins can either cancel each other out, so they can, like, average out to 0, or there can be a bias in the spins. The spins can all be pointing in one direction. If that happens, then you get a magnet. Explain double slit without a creator? Yeah, so the double slit, as understood by mainstream physicists, is that when you take a particle, you pass it through the two slits. If you want to figure out which slit it passed through, you have to interact with it somehow. You have to bounce a photon off of it. You have to put a magnet underneath it, something like that. Something that interacts with it. But if you interact with it, then you're going to affect its behavior. So of course it's going to change the way it behaves. You're doing something to it. Why is phi significant? It's not. It's not. I've never seen phi show up in a physics equation, ever. Do you think the collapse of the wave function is a real phenomenon? No, I kind of don't. Would quantum computing be easier in space due to the heat problem and the fact that it's already super cold, or would the heat dissipate too slowly without active cooling? The latter. I think it'd be the latter. Is it physically possible to magnetize cheese, and why? No, I don't know. I would Google that. I imagine that Google's AI would probably have a good answer for that question. How sick are you of having to break down the double slit experiment? I'm pretty sick of it, to be honest, but I will keep doing it because it must be done. Will cold fusion ever be possible? I suspect not. So there is something called muon-induced cold fusion, or muon-catalyzed cold fusion rather, which is possible, but that's not practical. Cold fusion of just shoving protons together using some sort of catalyst, though, like some sort of chemical catalyst that is stable, no, that's probably a hoax. Is Maxwell's equation an important equation to remember in physics? So Maxwell's equations are 4 equations, or I guess you can write them in the form of one equation, in the form of 2 equations, I guess. df and d star f are both, so df is 0 and d star f is the current, but those are very, very important. They're like critical. From premium user with the $9.99 super chat. Thank you so much. That's so generous. If past, present, and future are all equally real, what defines the present? Is present just a perception due to how we write memory? Yeah, it would basically be that. Yep. If empty space is full of quantum fluctuations, should we stop calling it empty? It can't get any emptier than that, right? So you may as well. What will time travel be possible in the future? We can already travel to the future. We just can't travel to the past. Who's your favorite physicist? It's got to be my boy, Albert Einstein, the GOAT, right? Does anything in our solar system have matter density higher than the sun? Yeah, the sun's density is not very high. In fact, if I remember correctly, it's actually lower than Earth's density. Yeah, the sun's density is 1.41 grams per cubic centimeter, and Earth's density is like 3.5 grams per cubic centimeter or something like that. So yeah, the sun isn't very dense, it's just really big. What's your YouTube? You asked us to follow. Oh yeah, let me shill it again. So you guys should all go subscribe to my new YouTube channel, not the main YouTube channel, the new YouTube channel where debate clips and debunking content will appear exclusively. The YouTube channel is Dr. Blitz Debunks, and you should absolutely go subscribe. I want to get it to 1,000 as soon as possible so that it can be monetized. It's currently at 200. My main channel has 25,000 subscribers, so make sure to go, if you subscribe to the main channel, subscribe to the new channel as well. I want to get it monetized ASAP so that the clips can start actually providing me some passive income, because that'd be really good. Honestly, that'd be just really good. And if you're watching on YouTube and you want to find it, go to the link tree in my bio. It's underneath the main channel YouTube link. So yeah, that's the shill. Also, join the Discord server. You should do that. Do you professionally teach, or would you ever? So I'm not teaching at a university right now. This is in some sense professional teaching. I make money doing it and I'm teaching, so professional teaching. Make of that what you will. But yeah, I'm applying for postdocs this season, and so some of those postdocs involve teaching, so I might do that. I might do that next year. What do you mean by we can already travel to the future? Yeah, we're doing it right now, right? We are currently traveling to the future, right? Yeah, it is true. If you subscribe to the new YouTube channel, you gain +6 cool points. That is proven. It's been scientifically proven. Is a postdoc good? Postdocs are good academically. If my goal is to be a professor at some point in the future, which it is, then postdocs are kind of necessary, yeah. What's your opinion on string theory? I think it's a beautiful theory that describes some universe that's not ours. Oh, hey, Godless Engineer. Yeah, you should have me on your channel. You absolutely should. I didn't know that you were on TikTok, Godless Engineer. I had no idea. Okay, cool. Maybe I should have known that. What makes people so sure that dark matter is made up of just one substance or component? Not necessarily. It's not necessarily just one substance or component, but it's something. Now, the simplest explanation is one substance or component, but there are other people who are investigating other ideas. Can light theoretically move at a different speed depending on the direction? You're talking about anisotropy. So, in principle, you could make it's called a, what is it? Synchronization convention, so that that's the case. But it's not, it doesn't really affect any observations if that were the case. Did you debunk some Teslasms on your channel? So the current channel doesn't have any shorts on it yet. It only has 2 videos on it so far. But if you want to stay up to date on them, they will be posted there, so make sure to sub. Hello, Blitz PhD. Without propulsion, what other options could one have to move in zero gravity? You need propulsion to move in zero gravity. That's the whole business. I guess you could use gravitational fields of other things if you happen to get lucky, but to get yourself into those positions where you could get lucky, you need propulsion. What's your PhD field thesis? So I did my research on conformal geometry with applications to general relativity and the ADS-CFT correspondence in particular. Do you believe in white holes? No. From Joseph Silver with the $5, thank you so much, as always. 3rd year undergrad in astronomical and planetary science, data science minor. How do you push past burnout, raising a child, working, attending uni? Look, so your struggle is a lot harder than my struggle. I was an 18 to 22-year-old when I was an undergrad. I had essentially no obligations. I mean, I worked, but like I worked in a lab for a few years, and I worked at Boston Market for a few years as well. But I had like no obligations. You have a lot of obligations, and so it's going to be hard. I just didn't experience burnout because my obligation load was just fairly low. I was lucky. How to push past burnout? I think that this is what I've heard. I've never experienced burnout, but what I've heard is that taking a step away from things for some time can be really, really helpful. Like just go be in nature for a week. That can be a good way to reset. That's what I've heard anyway. But I understand that you have kids, you're working, you're attending uni, you might not be able to do that, in which case I don't know. TikTok being your hobby and your job is wild. Yeah, absolutely, right? It like honestly, the live stream. So if you guys don't know, when I do the debate live streams, they account for about 10% of my income, which is sizable, but like not a lot. And I put more time into that than I do into the other stuff. And I do it solely for the love of the game. Like the debate stuff, it's just the love of the game. Like I just love doing it. That's why I spend like 3 hours on it every weekday, right? Even though it accounts for like 10%, like less than 10% of my income, realistically. Anyway, do you know what the hard star operator is? Yeah. It's when you, it's the dualization operator that takes say a K form to an N minus K form. Yeah, absolutely. If you weren't there, I referenced it when talking about the Maxwell field equations, where D star F is your current density. Are you currently working on a theory yourself? Well, kind of, sort of. There's one that's currently being peer reviewed. At least I hope it's being peer reviewed. Karason with the $5. Do you think there's good reason to believe that such a thing as a unified field theory or theory of everything exists and/or is discoverable? I'm hopeful that there is, but maybe there's not. I think that there probably is some underlying mechanism, but we might not be ever able to discover it. Who do you main in Marvel Rivals? So I haven't played Rivals in a while. I just haven't played video games in a while. But when I do play Rivals, I play Magic. I play Magic and Magic alone. That's basically it. Do you watch Skinwalker Ranch? Nope, never read it. Or never watched it. Do you think that string theory will be the theory to solve the quantum gravity problem? No, I don't think it will. I think that it requires supersymmetry, and our universe doesn't have supersymmetry. Do you plan on staying on TikTok after it changes hands? Yes, it is my primary source of income, so I will stay on it. You know, most of my content is science communication, and that's the kind of thing that makes TikTok look really good. Like like science communication is really good for PR, educational content in general. So I have a feeling that they probably won't touch it very much. If they do, then I might leave, but I suspect I won't. Can entanglement be used for Morse code to enable instant communication across spacetime? No. So there's something called the no communication theorem. The point is you can't control what the outcome of your entanglement is. You also can't tell if the particle has been measured. You can't tell, what am I trying to say? You have two entangled particles, particle A, particle B. If person A wants to communicate with B, what you can't do is you cannot force the collapse of the wave function to appear in a certain state. You can't do that. It's probabilistic. The second thing is that even once you make a measurement, the other person doesn't know if you've made a measurement yet. They don't know until they come back and talk to you and confirm, oh, you know, I got all these correlations because you were making all of these measurements. Sorry, my nose is so itchy. Is it mainly math or like theory when you took your education? Oh, it was both. Why inside of a car, when you throw an object up, it moves relative to the car, not relative to the Earth? How does that work? Because when you threw it up, it started out moving. It was moving with the car, so it doesn't lose that speed. Is there a framework that unifies quantum noise with classical thermal noise, or are they fundamentally separate domains? Yes, there is, sort of. There are things called classical quantum somethings. I don't remember what the paper was, but there's a recent paper on it that was studying kind of like the merging of classical and quantum systems. Let me see if I can find it. Yeah, so there's a paper by Masahiro Hotta, Sebastian Merck, and Daniel Turno. This was in June of this year, called Classical Quantum Systems Breaking Conservation Laws. So people study this kind of thing all the time. It's quite interesting. Is there an equation someone can solve right now to win a Nobel Prize? No, not really. Do you think it's possible for telekinesis to exist? Not really. Did you see the video the guy made about you proving you're wrong about bells? Maybe, I don't know. Much less action. Okay. Blitz, what can we plebeians do to combat misinformation? Well, okay, I guess that, so if you're on TikTok or on YouTube or whatever, you can report it. It probably won't do anything, but if enough people do it, I imagine it would get taken down. What you can do is, okay, so realistically, leaving comments probably helps them. And the comments, like, it's probably not a good idea to leave comments. Realistically, the thing that you can probably do is you can probably scroll past them really quickly on TikTok or just not watch them on YouTube. You can, or if you see them on YouTube, say, I'm not interested or whatever on those videos, and then just support the people who are debunking it. Like, not to shill for myself, but like, the more people we can encourage to make debunking videos, the more we can saturate the market with it, and the less likely people are to see the original video rather than the debunking video. So that's I don't know what else to do if you're like a plebeian normie, right? Powerwolf or Dragon Force? Powerwolf the whole time. If nothing can escape a black hole, not even light, how does it emit radiation? Well, nothing can escape a black hole classically, but in a quantum system, in a quantum field theory, in a curved spacetime, which is what you can do, it's called semi-classical gravity, or it's not necessarily called semi-classical gravity. Quantum field theory in a curved spacetime, you can show that stuff actually does leak out. And the way that you can think about it is that you can think of it as quantum tunneling outside of the event horizon. Powerwolf over Dragon Force? Yeah, I just like Powerwolf more. I've seen them both. In fact, I've seen them both twice. I just like Powerwolf more. Dreading getting into more intense math for my sciences. Is finite math and applied calc much harder? Finite math is conceptually difficult, but it's not computationally difficult. It doesn't take a very long time. Applied calc, I don't know if is that different from regular calculus, because if it's not, then calculus is just calculus. It's the same thing that you'll see everywhere. And I think that everybody could learn calculus. God, my nose is so itchy. Okay. If the laws of physics are time symmetric, why do we only experience time moving forward? That is a great question. And likely it's because we experience time moving in the direction of entropy increase. And in the past, the entropy was lower. So we experience time in the opposite direction of the past. If the entropy was highest in the past, then we would experience time in the other direction, towards the past, I guess. Not everyone could learn calculus. There are a ton of very not smart people. No, I think that calculus is within the realm of possibility for everybody. What do you mean by an infinite number of steps in quantizing gravity? Can you briefly pull up a whiteboard and explain? I don't have a whiteboard. I really need to get one, but the office that I'm in is fairly small, and I already have a permanent green screen behind me. Not a permanent green screen, but just a green screen sheet behind me. I just don't have room. But essentially, so when you do renormalization, you basically have to add terms to cancel out infinities. But or when you convert from a classical theory to a quantum theory, naively, if you just start with the classical theory, you'll have infinities everywhere. So you have to add terms to your classical theory to renormalize, to get rid of the infinities. But there's just, every time you add a term, you'll get another infinity that you have to cancel out. And so you just have to keep doing it forever and ever. Do you have any physics hot takes? Not in any pseudoscientific sense, but in like some speculative physics. Yeah, I think that entropy can reverse if the universe starts to cycle back. At least that's possible. I think that that's at least fundamentally possible, and I think that that's probably a hot take. Does time dilation affect the expansion of space-time? If so, could it account for dark energy in any meaningful way? There's a small group out of New Zealand that thinks that this is the case. That thinks that time dilation is actually responsible for, they call it the timescape model. It is a very fringe view. Most physicists think that time dilation doesn't play any role in expansion. Do you think the universe is cyclic? I think it's at least possible. Is the second law of thermodynamics fundamental or a statistical law? I think it's, I mean, it's like well known to be a statistical law. Can we store antimatter transforming into energy? Yeah, we can store antimatter, just not for very long. Unfortunately. All right, y'all, we have been live for just about 2 hours, and I'm going to lose my voice if I keep at this. But before I go, make sure to go subscribe to the new YouTube channel. The new YouTube channel is called Dr. Blitz Debunks. It's where I will be putting all of my debunking content that you can find it on. I will put all of my debunking content on there. You'll find clips from the debates, so you can watch the individual debates rather than the whole live stream with all of the stuff, all of the filler stuff, all of the super chats and stuff. You can just go watch the clips of each individual debate on this YouTube channel. So go subscribe to it. I want to get it to 1,000 subscribers by tomorrow. There are, you know, on the order of 500 of you in here on YouTube and on TikTok. If everybody went and subscribed, we would be at like 600 by now. So make sure to go do that. If you want to find it on TikTok, if you don't know how to get there, go to the link tree in my bio and click on the Dr. Blitz Debunks link in the link tree in my bio. So go do that. I'm going to end the live here. I will see you tomorrow for some more Ask a Physicist. Take care, everybody.